choice basically. Which of the following will react together to produce the paper? This is the rest of the multiple choice basically. Which of the following will react together to produce 2-ethoxypropane? Okay, so what you need to be looking for here is an alkoxide and a halide. And what we're looking for is kind of substitution into the alkoxide. So what we're looking for here, I need to make 2-ethoxypropane. So that means I need a prop where the oxygen can then attach to make the eth group, and then I'm going to attach 2 carbons onto the end of that. Okay, so what I need here would be a sodium group, and on this bit underneath it I'm going to need some kind of halide. Okay, and then you just go looking for what could give you this here, and it's essential that you've got the halide on carbon 2. Okay, so which is why it is D. So you've got to know what you're looking for, and then you've got to be able to find the right ones in that one. Okay, question 17. Aldehydes can be converted into alcohols by the reaction shown. Which of the following aldehydes would produce a primary alcohol? So it's kind of a higher question almost. Not totally, but you know, the idea behind it is still higher, I think. Right, so what you're looking for in a primary alcohol is that the OH group, that the hydroxyl attached to the carbon, this carbon only has a maximum of 1 carbon attached to it. So 1 R group, and the rest have to be hydrogen. Okay. So you've got a process here which is adding a CH3 group from here onto an aldehyde. Okay. The R group that they've got up the top here on the original aldehyde remains, but we've got an additional CH3. Now, if you look at this, you're like, okay, so since I'm adding in a CH3 and I want it to be a primary alcohol, the only thing I could have up the top on this R prime is an H group. Okay, so the only thing I could use here is methanol. Just to draw, if we're clear. Okay, this would be methanol. Put it through the process that it's telling you about here. It would give you this grouping, and that is a primary alcohol. Okay, or if we had ethanol, okay, using again the way that they've shown us this, so this would be a CH3 group as well, making the eth and or eth, I suppose, and then we're going to add to this, but this time we're going to substitute off, or substitute in rather, here we're going to keep our R group as a CH3. This is an H, and now we're sticking on our CH3 on this side as well. So this carbon here now has 2 carbons attached to it, so that is now secondary. Okay, that's the question. Question 18. This reaction is an example of, and you've been given a wee pile. Okay, so right, hydration means I need to add water to a molecule. You know, normally we're talking about an OH and an H. Not normally, that's what we're talking about. We're not doing that. We're not adding that into a chemical. Okay, hydrolysis means I need to break a condensation link. So I'm going to end up with 2 smaller molecules, but I'm going to have to add in a small molecule to make that work. Dehydration has got to be a removal of water from 1 molecule, which is not happening here because I've got 2 things going in to get the water. And condensation, I'm doing that. Condensation is to putting 2 smaller molecules to make a larger molecule with removal of a small molecule to create the join. Okay. And 19. When but1ene reacts with hydrogen chloride, 1 chlorobutane and 2 chlorobutane are formed according to Markovnikov's rule. Okay, you're being asked about what would happen, so let's just put but down here. But1, stick in my hydrogens. Okay, Markovnikov says that if I'm adding in this, okay, basically the hydrogens will go with where the more hydrogens are, and the other one will go where there are less. So I'm going to add my hydrogen in here, get rid of the double bond, and I'm going to add my chloride in here. This is the most likely. So I'm going to be more likely to produce 2-chlorobutane than 1. It's definitely not 1 than 2. It's not going to be equal. The whole point is it's more likely that you get one thing than the other. And this impossible to tell relative proportion of each product has got nothing to do with Markovnikov's rule. Okay. When 2-bromobutane reacts with ethanolic potassium cyanide and the compound formed is hydrolyzed with dilute acid, final product is. Okay, so just being careful. 2-bromobutane, 1, 2, 3, 4. Bromine off here. Okay, and the rest of these quite happily filled in with hydrogens. Okay, we are going to react this with potassium cyanide. So what that will do is substitute here, so we get a cyano group attached onto this carbon. Okay, now that we've got that here, what you can then do, which is the next part, hydrolyzing with dilute acid, and we can alter this bit here, so this becomes a C double bond O bond OH, so we basically make it a carboxylic acid. Now you need to know that process for you then to name it. So what we've produced is, here's our longest chain. Remember the nitrogen's gone. Okay, so I've got 4, so I've got a butanoic acid, and we number from the carboxylic acid group. So 1, 2, I've got 2-methyl butanoic acid. You just have to remember that you add in an extra carbon if you're adding in your cyano groups. Question 21. Which line in the table correctly identifies W, X, Y and Z in the reaction sequence? Okay, I looked at this one, and the first thing I did was look for something that I knew was happening, and I think the easiest one is that we have a double bond here on number 4, and that means that I'm expecting that I can make this or I can break this. Okay, so making this, the simplest thing to do would be from number 2, I could dehydrate off water, and that would give me a double bond. So 2 to 4, I am happy would be a dehydration. I'm also happy that from 4 to 1, look at what's happened here, 4 to 1 is going to be an addition. Now, just with those two, I've got to have the answer, but just to prove where we're at, okay? So 2 to 4 is a dehydration, so that would mean 2 would be X and 4 would be Y. Now, actually, here's my 2. I've got that on that first thing, if that was the one I picked, okay? But if I'd gone with the addition, I would have decided that 4 was Y, and I would have decided Z was 1. The only one that's possible, again, so we're already there. And finally, we have 3 is your ketone, and there's your secondary alcohol over there. So 3 going back to the alcohol is reduction. So 3 here for that one. And yeah, so whichever one you picked to go with, if you were lucky and went with this one first, 2 to 4, then that would have got you the right answer straight away. If you'd gone with 4 to 1, the addition, that would have got you the answer straight away. If you'd gone with the reduction, that wouldn't quite have got you the answer. You would have needed to do one of the other ones. But there you go, that's it. Which of the following statements about benzene is not true? Okay, so benzene, you should know, is your nice, even, I'm trying to get it even, delocalized electron set in the middle, and these obviously have hydrogens off the side as well between each carbon, right? So it is planar, is true, because what we've got here is sp2 hybridization, which means that each carbon atom is attached to 2 other carbon atoms and a hydrogen at a perfectly planar 120 degrees between each one. Okay, so this is all planar. Okay, so that's not true. It is susceptible to attack by electrophilic reagents. We have a delocalized cloud of electrons. They are definitely going to pull in electrophilic reagents as a choice. Okay, carbon to carbon bonds are equal in length. Absolutely, otherwise we wouldn't have a perfectly even ring. It is readily attacked by bromine. No, because although this is a point which can be attacked, we have a really good stability in this ring, and because of that it makes it less ready to be changed. And it's not a double bond, it's a so we're not looking at a straight easy addition. What we're looking at is this delocalized ring, which keeps on restabilizing it. Question 23. Above reaction proceeds via an SN1 mechanism. Just going to make that a bit bigger. Okay, what effect will doubling the concentration of hydroxide ions have on the reaction rate? Okay, so you need to know your stuff, obviously. SN1 means that we are looking at one thing having an impact on rate. And what you should know as an example of this is that we're looking at the alkyl halide, and it is tertiary in terms of what is going to be the impact on the SN1 mechanism. So this is what impacts the rate. This has nothing to do with it. So doubling concentration of hydroxide ions has no effect. It's not halved, it's not doubled, and it won't increase by a factor of 4. Just got to know it. Okay. Again, just make this a little bit bigger. Which of the following shows the splitting patterns for the circled H atom above in a high resolution proton NMR? Okay, so we're looking at this hydrogen, which is the same as looking at this hydrogen. Okay, and for the splitting, what we're looking for is hydrogens that it's next to. Okay, so this has next to it 3 hydrogens which are in a different environment, so therefore using your n+1 rule, it's going to go to a quartet. Okay. Question 25. Right, we've got 3 diagrams here. It's not, I realise that I should have maybe copied an extra one, but you can hopefully still see clearly. Okay, we've got noradrenaline, phenylephrine, and amphetamine. Okay, noradrenaline and phenylephrine stimulate receptors in the body, resulting in increased blood pressure. Amphetamine has the same effect, but works indirectly in the body by stimulating production of noradrenaline. The structural fragment acting directly, it's in bold, on the receptor is. Now, so what that basically means is totally ignore the amphetamine, because that says it has the same effect but works indirectly, and we're looking for directly. And now you've just got to find the pharmacophore, so we're just looking for the same bits. So definitely the benzene ring is in, the OH down the bottom is in, but not the one to the left. This carbon, all good. Hydrogen, hydroxide, yep. This carbon, yes. 2 hydrogens off it, agree. Nitrogen, hydrogen up, there, that's it. Okay, nothing else is part of it. And then you just got to find that fragment. That gives you D. Right, in a UK workplace, the maximum short-term exposure for carbon monoxide is 200 parts per million in a 15-minute period. If a person breathes in 134 grams of air in a 15-minute period, what is the mass of carbon monoxide breathed in at the maximum short-term exposure limit? Okay, what you have to remember is that parts per million is 1 meg per kilogram. So that means 1 milligram in 1,000 grams. Right, so if you have 200 parts per million, that is 200 milligrams in 1 kilogram, which equals 200 milligrams in 1,000 grams. Okay, now if you got that far, then all we're looking for is a straight proportion. Okay, so what we're saying is 1,000 grams is 200 parts per million. How much is 134 grams? Because that's how much they said you breathed in. So 134 divided by 1,000 times by 200 gets you 26.8 milligrams. Okay, 27. Sodium hydroxide is unsuitable for use as a primary standard because it. Okay, so primary standards, it gives you kind of a reasonable, nice thing about them. So primary standards have to be completely soluble in water. If they don't, or other things, as long as they're completely soluble. But this one they're saying it wouldn't make it unsuitable for use, it would make it really suitable that it's readily soluble. So it's not that, okay? Available in a high degree of purity. Well, that's essential for primary standards, so that's not the problem either. It's corrosive. Well, that's true, but that's got nothing to do with it as a primary standard. If the chemical you need to use is corrosive, you just have to be more careful with what you're doing and work out the hazards. So it's not because it's corrosive that it's unsuitable. So we're left with this one, or you might have gone to it straight away. Readily absorbs water from the atmosphere is a problem because what that's going to do is increase the mass, which means it's going to make it very difficult for you to get an accurate measure of the mass that you're using to make up your primary standard solution. Okay. Question 28. Okay, what volume of a 0.25 molar calcium nitrate is required to make by dilution with water 500 centimeters cubed of a solution with a nitrate ion concentration of 0.1? Okay, lots of ways around you can do this. So I have gone with moles concentration times volume. I'm going to work out the moles of nitrate that I'm going to have, okay? So in this solution, I want to have 0.1 molar and 500 centimeters cubed of it, which means that I need 0.05 moles of nitrate. That's how much nitrate I need in the solution. Now, you're going to have to work out exactly what your formula is. So sodium, calcium and nitrate. Nitrate is a valency of 1, calcium is 2, cross it over means that we have a formula of CaNO3 2. Now what that means is that if I want 0.05 moles of nitrate, okay, I am going to get that from 0.025 moles of my calcium nitrate, okay, because this is a 2 to 1. 2 of these for every 1 formula unit, okay. So I've got 0.025 moles of calcium nitrate. So now I just need to work out how much of that I'm actually going to use of my original stock solution that I've got here. So I'm going to go for volume is moles over concentration. 0.025 is how many moles of calcium nitrate I need. Divide that by concentration, 0.25 gives me 0.1, which is 100 centimeters cubed, because that's litres. Okay. 29. Oh, if I can get the mouse to come down, there we go. 1.6 grams of an anhydrous metal sulfate were dissolved in water. Addition of excess barium chloride solution resulted in the precipitation of 2.33 grams of barium sulfate. Original substance what? Okay, right, so what you're going to do first is work out the moles of barium sulfate. Okay, just barium's group 2, sulfate has a 2, so hence the formula. Okay, so let's work out the formula mass of barium sulfate. So barium is 137.3, sulfur is 32.1, and oxygen is 16, so 4 of them 64, gives you a total of 233.4. They're not being horrible because moles is mass divided by formula mass, so 2.33 divided by 233.4 means that we are looking at 0.01 moles. Okay, now we're not done obviously. Every single one of these we can use just by saying, okay, so here's barium sulfate. For every barium sulfate that we get, that was 1 sulfate, okay, and all of these we can work from for that. Okay, so what we're saying is that I'm looking for 0.01 moles of sulfate in 1.6 grams. So I'm looking for something which gives me 100th of that. So simplest way to do it, to be honest, is just to rattle through them. And so if I just take my sulfate here, that's 96.1. Add in copper, and that's 63.5. That gives me 159.6. I'll divide that by 100. And I get 1.6 grams. So there's your right one. And that is probably the easiest way to run this. Not even probably, this is the easiest way to run this. Magnesium sulfate, you can do exactly the same thing too. Sodium sulfate, be a little bit more careful because the moles of barium sulfate in sodium sulfate, you have 2 sodiums, so your mass is slightly different. But actually your sulfate's still the same, so that's not actually a problem. And the same with calcium. So overall, yeah, it's all good. You just do the same thing, just add in and calculate, and it's copper is your answer. Last one in the paper, okay, and not the nicest, not hideous though. Okay, so what we're looking at here is it asks you if you have 0.02 moles of the salt and you're given it's a platinum salt with ammonia X times, you're trying to work out this, 2 chloride or a dichloride, required 20 centimeters cubed of 4 molar nitric acid to react completely with the NH3 ligands. The value of X is. Okay, so if I'm reacting nitric acid with ammonia, what I'm making is my ammonium nitrate. Okay. And it's a 1-to-1. So for every mole of nitric acid that I use, I'm going to attach to 1 ammonia. So moles, concentration times volume, 4 times 0.02 gives me 0.08. Okay, that means that I used 0.08 moles of nitric. Now be very careful that you don't just jump into this one here. Got to do this bit here first. Okay, it was 0.02 moles of the salt, and my nitric was 0.08. That cancels down. It means for every 1 mole of salt I needed 4 moles of nitric, so for every one of these I had 4 in here. Why, it's B. And that's your whole lot.